Okay, for this curve, we will find the range of values that y can have. Now, when you have something quadratic in your rational function, so there is an alternative method there to determine the values of y that it can have. Okay, so you just cross multiply it. You have x squared minus xy plus 3y that is equal to 0. Now this is a quadratic equation in x where your a is 1, your b is minus y, and your c is 3y. Okay, if you put the discriminant as negative, you can determine the values that y cannot have. Okay, and then you will find its complement, so that will be the answer to this question. So this b square is y square minus 4ac, that is minus 12y, that is,
Sir,
yes beta,
sir x square minus xy minus 3y नहीं होगा?
square minus, yeah, I have skipped a step here. You're absolutely right, this should be minus. Thank you beta, this is minus. So this should be minus. Then there is a plus over here, okay? Thank you, Beta, for timely mentioning this mistake. Okay. So now this tells us that y is between minus 12 and 0. So these are the values that y cannot have. Okay. So then what are the values that y can have? Y is going to be greater than or equal to 0, or y is going to be less than or equal to minus 12. Now let's see that if we can find the same values through its sketch. Okay, so this is y is equal to x squared over x plus 3. This is an improper fraction, so I will divide this first of all. This is x squared, x plus 3, x squared plus 3x. This cancel, so minus 3x. So I have here minus 3, minus 3x, minus 9. So we have 9. So the same function can be written as x plus 3 and then plus 9 over x minus 3. So this will have an oblique asymptote here. Okay. So x plus 3 means is 1, 2, 3, 1. You must be very quick in drawing this line, okay? So this is your oblique asymptote. This is 3 here, this is minus 3 here, this is 0 here, okay? And then there is a vertical asymptote, that is x equal to 3. So we have a
सर नहीं, ये x minus 3 plus 9 over x plus 3 नहीं होगा?
I'm making so many mistakes. I'm so sorry. So this has to be, the asymptote has to be at x equal to minus 3. So here is that asymptote, okay?
The oblique asymptote will also be
Yeah,
neutral.
at minus 3. Thank you, beta. Thank you. I'm a bit drowsy today. I slept very late last night, okay? So
It's all right, sir.
that's why we must be mentally alert, and especially when we are dealing with the further mathematics. Okay, thank you very much, Beta. Now, this is the case here that we have this is your, can you just erase this? Okay, now, so we are ready with the oblique asymptote and the, this.
Sir, oblique asymptote नीचे बनाना है.
Yes, Beta?
The oblique asymptote has to pass through minus 3.
Yeah, this is the vertical asymptote, and both the oblique line is also passing through this minus 3. Yes. Because
I mean on the y-axis. It was y is equal to x minus 3. Your quotient is x minus 3.
I just This had to be -3. Come on, you were late in telling this. Okay, I need to draw this again. Mhm. Yes. You see, this happens. I think I switched them. Um, I switched them. One was -3, the other was +3. Okay, so this is your 1, 2, and this is -3. Is this right now if I draw it like this?
Yes.
So now this is right. Yeah. Okay. Yes, so now we are ready to draw this. Now let's see if we have any turning points on this. So I will be using this. This is easier to differentiate x minus 3 plus 9 over x plus 3. So my dy by dx is going to be 1 minus 9 over. Please keep an eye on this. Okay, I'll put that equal to 0. So we have x plus 3 whole square equal to 9. X plus 3 is plus minus 3. X is going to be minus 6, or x is going to be 0. So we have a turning point at -6, and then we have a turning point at 0. Okay, so this is 1, 2, 3. Here it is your -6. Okay, now quickly tell me when I put 0 here, what do I get? This is going to be -3. Yeah, this is going to be 0, 0. Hmm? When I put x
And I
as
think
that is 0.
-12. Mm,
When your x is 0, your y is 0.
oh,
So that means here is a turning point that we're having. Okay. So I am going to imagine that the curve is going to be coming from the infinity and, like, reaching this and then going with this asymptote here, like this. Okay. You can draw this a bit smoother. Like I have my this E pen. So this is really a very annoying kind of a pen over here. Okay. So this one is okay. So uh, the other part is going to be, if I had taken an appropriate scale over here, then I could have shown it. Now just put this -6 into the uh, -6, put that -6 into this equation here. So that is going to be y equal to -9 and plus, this is -3. So y is -12. So we shall have that turning point somewhere over here, okay? And the curve would be like coming from the infinity here and then going downwards like this, okay? So here you have, this is your um, -12, okay? And this is your 0 over here. You see that the values that we have calculated over here. So we were able to calculate these values because this was a quadratic. We could write a quadratic equation in x. Okay. So you see that the sketch is giving us the same values. One is more than or equal to 0, and the other is less than or equal to -12. So we have practiced the rational uh, functions sketch with an oblique asymptote and with a vertical asymptote. You see that we determined the turning points over here, and we didn't need to have the x-intercept and the y-intercept because this was the same here. The 0, 0 is both x and y-intercept. I hope you got it. Please see if there is any problem with this or any question.